Alright, so find the critical points of the following function, give what the first order derivative, set them equal to 0, and solve. Alright, so we're going to do kind of an example of each kind of method. Alright, so the first one is actually the special case where it's not really going to be a system. Alright, so find your first order derivatives, set them equal to 0, again that's a key step, and then solve using algebra. Alright, so f sub x, again there are only two x values, there's the x squared and the negative 52x, so I get 2x minus 52, set it equal to 0, and I'll solve in a second. I'm going to go ahead and find my f sub y and set it equal to 0. Alright, so there's only two y values. There's the y squared and the 134y. So I get 2y plus 134, set it equal to 0. Alright, I have to solve the system where they're both equal to 0, and so that's a key step you have to show. Alright, now this is the special case. It's not a system of equations because there's only an x term in the first and there's only a y term in the second. Alright, and so in this case, I just solve each individual equation for the variable I'm looking for. So the first equation has the x I solve for, so this one I solve for x. And this one I solve for y. Alright, so I add my 52, and so I get 2x equals 52, divide by 2, and so my x value in my critical point is 26. Do the same thing for y. So y comes out negative 67, and there's my critical point. Alright, so the critical point is 26, negative 6, and it is in the domain. It's a again, most of ours will be all real numbers work, right? I can plug anything I want into f of x. And so this would either give me, and so this would be the possible place where I could have max or min, or neither. Again, the same thing like we did the first order derivatives. Alright, I'm going to go ahead and do problem 2. Alright, so I've got my x squared y cubed minus 18. As soon as I see this y cubed, I already know that it's going to have to solve with the substitution case. Alright, because I'm going to have a square term. Alright, so I'm going to do my first order derivatives and set them equal to 0. Alright, so there's two x terms. There's the x squared minus 18xy. So I get 2x minus 18y, set it equal to 0. F sub y is the y cubed, so 3y squared minus 18x set equal to 0. And so you'll see both of these equations have an x term and a y term. The second one has a y squared. Alright, so I can't use the method I had in the last example because I've got mixed, so it's a system. They're not linear because I have the y squared term, so I can't use a matrix, and so this one I have to use the substitution method. Alright, again, there's more than one way to go with this, but in this case, the easier way to go is to solve this equation for x and substitute it into here. Alright, so I'm going to solve this one for x. Alright, which means I'm going to move the 18y to the other side. So, plus 18y. So 2x equals 18y, divide by 2, and so x equals, x equals 9y, right? 18 divided by 2 gives me my 9y. And so that means for every x value, the y value that's paired with it so for every y value, the x value paired with it is 9 times that value. Alright, so that's what's going to go up in here for x. So I replace the x with 9 times y, so I get 3y squared minus 18 times 9y, set equal to 0. Alright, so 3y squared, 18 times 9, comes out 162. And we always solve these by either factoring or using the quadratic formula. Alright, don't try to solve for y, because if you do, you'll lose one of your points. I'm going to factor. This one's actually not too bad to factor. I can pull out both a 3 and I can factor out a y. So I can pull out a 3y. When I do, I'm left with y, right, dividing out. 3y squared divided by 3y gives me just a y. 162 divided by 3 gives me out 54, and the y came out, set equal to 0. And so I get 3y equals 0, or y minus 54 equals 0. So y equals 0, or y equals 54. Right, and those are so there's two critical points. There's a critical point at y is 0, and there's a critical point at y equals 54. Well, now I have to find the x value. Well, you find the x value by plugging those back into this equation, right? If I plug 0 in, I get 0 out. If I plug 54 in, well, I get 9 times 54, which is 486. And so I have 2 critical points. At 0, 0, and at 486, 54. Be careful with this one. Remember, the 46 is the x value paired with the y value 54. A lot of times students will flip those. Right? Make sure you're careful with that. And so those are my possible places where I could have extrema. Alright, so that was the case where we have to use substitution. The last case, or the third case, I did one of each case here in the first 3 examples. And so this is going to be the matrix case. Alright, so I already know it's going to come out linear. Alright, so I find my first order derivatives. Oops, P, not F. P sub x comes out negative x to the first. That zeroes away. Negative 4y plus 1920 set equal to 0. P sub y, negative 12y minus 4x plus 1600 equals 0. These are both linear. Right? There's a single x term, a single y term, and a constant term. Now, in order to use a matrix, you have to put them in the form ax plus by equals c. Alright, so I've got to make sure x is first, y is second, move my constant over. And so in the first one, it's negative 8x minus 4y. I move this to the other side. Well, when I move it to the other side, I subtract it. So make sure you're careful. It's negative 1920 when I move it to the other side. And the same thing for the second one. Now, the second one, you have to be careful of 2 things. You have to reorder x first, y second, and then move the 1600 to the other side. So you get negative 4x first, then minus 12y, and then you move over the 1600, and so it's negative 1600. Now, when you go plug this into the calculator, since everything is negative, if you multiply by a negative 1 by everything, it will give you the same exact line. Alright, so when you go to plug this into your matrix in your calculator, so you're gonna, and I'm going to go, I will show you how to do this. It's going to be a 2 by 3 size. Your row 1 is your equation 1, row 2 is your equation 2. So you're going to get negative 8, and you can actually plug them in as positives. You can also leave them as negatives, but 1920. I think of it as multiplying the whole thing by a negative to get rid of the negative. Alright, then you do your row reduced echelon form, if you remember from if you've taken 120 recently. Alright, if you don't, I will pop up my calculator and show you how to do that. Give me a second, because apparently I didn't have it open yet. Alright, so get out of the, so where the matrix is, if you have TI 84, 83. Alright, if you look here at this x to the negative 1 above that, and mine is in blue, it has the word matrix. So I have to hit the second, that x to the negative 1, and now I've got my matrix here where it names, math, edit. I want to go over to edit. Alright, I want to pick, oops. Alright, it needs to be a 2 by 3. Alright, then I carefully type it in. It was 8, 4, 1920. And it was 4, 12, 1600. Double check and make sure I plug those in right. 8, 4, 4, 12, 1920. Alright, quit. Go back into matrix. Now we're going to go over to math. And if you scroll all the way down, and it's off the page, it's all the way down at B, and you want to make sure, apparently I hit my button one too many times. One too many times. You want to make sure you pick the RREF. Alright, so make sure the double R, RREF, is up on your home screen. Then you go back into matrix one more time. Pick the matrix where we plugged it in, so I put it in matrix A. And then hit enter, and it will solve it for you. Alright, so we get 1, 0, 280, 0, 164. And so 208, I think I said 280, 208, 64. And so what this is well, this was an x value, this was a y value, and so the first line gives me my x value, x is 208. The second line gives me my y value, 64. And so there it solved it for you. If you solved it by substitution, you should get exactly the same thing, and you can always solve it by substitution. If you don't want to use the matrix method, you don't have to. You can always solve by substitution. And so we get one critical value, one critical point. X was 208, y was 64. Alright, and those were the three methods. Alright, we'll stop there and pick it up in the next video.